In the story of artificial intelligence, Nvidia isn't just a footnote, it's a cornerstone. As AI has advanced from theory to real-world application, Nvidia's GPUs have powered the rise of deep learning, turning ideas into breakthroughs and research into products. But what exactly makes Nvidia so vital to the AI revolution? Let's start at the beginning. Graphics processing units, or GPUs, were originally designed for one thing: rendering images and video. Their architecture was ideal for tasks that involved parallel processing, performing many calculations at the same time. While CPUs handled general-purpose tasks sequentially, GPUs could process thousands of tasks simultaneously. That made them perfect not just for graphics, but for a new frontier: machine learning. In 2012, deep learning exploded into mainstream AI thanks to a breakthrough in image recognition. Researchers using Nvidia GPUs trained a deep neural network called AlexNet to win the ImageNet competition by a wide margin. It was a turning point. The AI community realized that GPUs weren't just faster, they were the enablers of an entirely new scale of learning. Nvidia quickly pivoted. It launched CUDA, a parallel computing platform and programming model that let developers harness the full power of GPUs for AI workloads. CUDA became the foundation for training neural networks across fields, from healthcare to robotics to natural language processing. Then came the DGX systems, purpose-built AI supercomputers combining top-tier GPUs with optimized software and infrastructure. These machines are now the backbone of training large models, including those developed by OpenAI, Meta, and Google. So why are GPUs so critical to AI? Because training a modern deep learning model like GPT-4 requires processing massive amounts of data through millions or billions of parameters. Each training run might involve trillions of matrix operations. CPUs simply can't handle this scale efficiently. But GPUs, with their thousands of cores and high memory bandwidth, can. And no one does GPUs like Nvidia. Its chips, like the A100, H100, and the newly announced Blackwell series, are optimized for both training and inference. With innovations like Tensor Cores and NVLink, Nvidia's hardware delivers unmatched performance for AI developers and enterprises. But Nvidia isn't just about hardware. Its software ecosystem is just as important. CUDA, cuDNN, TensorRT, and the Nvidia AI Enterprise Suite provide end-to-end support for developers, researchers, and data scientists. Whether you're training a vision model in PyTorch or deploying an LLM in a production pipeline, Nvidia's software stack helps streamline the process. The result? Nvidia is at the heart of every stage of the AI workflow, from research to deployment. Its GPUs power data centers, supercomputers, and even edge devices. They're used in autonomous vehicles, smart cities, medical diagnostics, and real-time translation. And as generative AI becomes more demanding, the need for high-performance GPUs continues to rise. OpenAI, for example, used Nvidia A100s to train GPT-3 and GPT-4. The same is true for Anthropic's Claude, Meta's Llama, and Google's Gemini models. When we talk about large language models, we're really talking about the computing infrastructure underneath. And that means Nvidia. Beyond the chips, Nvidia is also building the foundations of AI infrastructure. It provides hardware for hyperscalers, tools for model optimization, and platforms for simulation and synthetic data generation. Its Omniverse platform blends AI with real-time 3D rendering and simulation, helping train AI agents in virtual environments before deploying them in the real world. But Nvidia's rise isn't just technical, it's strategic. As demand for generative AI exploded in 2023, Nvidia's valuation skyrocketed. It became one of the most valuable companies in the world, and its GPUs turned into the most sought-after resource in the AI industry. Companies weren't just competing for talent, they were competing for GPU capacity. That made Nvidia not just a supplier, but a gatekeeper. With limited chip supply and increasing global demand, access to Nvidia hardware became a bottleneck. Cloud providers raced to build new GPU clusters. AI startups built their business models around Nvidia-based infrastructure, and governments began to recognize GPU access as a strategic resource. Yet this success brings new challenges. There are growing concerns about energy consumption, chip scarcity, and the centralization of AI infrastructure. Nvidia has responded with innovations in power efficiency, multi-instance GPU, MEG support, and modular designs. Still, the world is watching to see how it balances growth with sustainability. Competition is also heating up. AMD and Intel are developing AI-focused chips. Google has its TPUs. Amazon has Inferentia. Startups like Cerebras and GraphCore are innovating with new architectures. But so far, Nvidia continues to lead, thanks to its first-mover advantage, deep ecosystem, and constant innovation. Looking ahead, Nvidia's role in AI isn't likely to shrink. In fact, it may expand. As we move toward agentic AI systems, real-time AI interaction, and personalized AI models, the need for low-latency, high-throughput hardware will only grow. Nvidia is already investing in next-gen chip design, quantum simulation, and edge AI, bringing intelligence to devices far beyond the data center. So what's the bottom line? Nvidia isn't just a chip maker, it's an AI enabler, a silent force behind the most powerful models of our time, a bridge between raw compute and machine intelligence. If AI is the new electricity, then Nvidia is building the power grid, and its role in shaping the future of intelligence is only just beginning. To fully appreciate Nvidia's role in AI, it's also important to understand how the company is adapting to the era of generative AI. One of the most exciting developments is Nvidia's focus on CX foundational models as a service. Through its partnerships with cloud providers like AWS, Microsoft Azure, and Google Cloud, Nvidia is enabling developers to train, fine-tune, and deploy massive models on demand, without needing their own GPU clusters. This democratizes AI in a powerful way. Small startups and research labs can now access the same infrastructure that powers giants like OpenAI and Meta. By offering pre-trained models, optimized frameworks, and fine-tuning tools, Nvidia is lowering the barrier to entry and expanding the developer ecosystem. And that's not all. In industries like healthcare, Nvidia is using its Clara platform to accelerate medical imaging, genomics, and drug discovery. In autonomous vehicles, its drive platform powers perception, planning, and simulation. In robotics, Nvidia's Isaac SDK helps developers train AI agents in simulated environments before deployment. Each of these sectors has one thing in common: the need for high-performance, AI-ready compute. Nvidia's influence is also growing through acquisitions and partnerships. Its purchase of Mellanox improved data transfer speeds in AI clusters. Its collaboration with ASM, despite a failed acquisition, hints at ambitions to expand into mobile and embedded AI. Its alliances with automotive and industrial leaders show that AI isn't limited to the cloud. It's going everywhere. This wide reach means Nvidia isn't just building the backbone of AI, it's shaping its distribution. Of course, with great power comes great scrutiny. Some experts worry about overdependence on a single provider. Others point to the environmental costs of massive GPU farms. There's also debate around access inequality. Not every country, company, or developer can afford to scale with Nvidia's top-tier chips. But Nvidia appears to be listening. It's investing in modular, energy-efficient designs. It's supporting open standards like ONX, and it's contributing to AI safety conversations through initiatives on explainability, federated learning, and responsible development. The Nvidia of today isn't just a tech vendor. It's a global AI player, operating at the intersection of innovation, policy, and infrastructure. In many ways, its GPUs have become the oil of the AI era, powering everything from recommendation engines to autonomous fleets. And as AI becomes more embedded in society, the systems we build will continue to rest on the hardware foundations Nvidia helped create. So the next time you ask ChatGPT a question, use an AI voice assistant or see a self-driving car in action. Chances are Nvidia played a part in making it possible. And as the demand for smarter, faster, and more ethical AI grows, so too will the role of the company that gave artificial intelligence its ultimate fuel, the GPU. In conclusion, Nvidia is more than a company. It's a catalyst. It sits at the core of the AI movement, driving both technical progress and global access. From silicon wafers to software stacks, from cloud platforms to embedded devices, Nvidia's impact is everywhere. As the world continues to shape what AI can and should be, Nvidia is building the machinery to turn those ideas into action. And in the decades to come, when we look back at how artificial intelligence changed everything, we'll see the unmistakable fingerprints of GPU-driven power, vision, and innovation. Nvidia didn't just power the AI revolution, it helped define it.